Hi, welcome back to this channel. This video we are going to discuss a few questions for chapter 7 Ionic Equilibrium. Let's start with question number 1. Choose the correct statement for the ethanoic acid with the concentration 2 exponent negative 3 molar. So we look at the option C. The acid ionized completely. This is wrong because ethanoic acid is a weak acid. So the Ka value will be increased with the increasing of concentration. So Ka value only will be affected by temperature. So option D also out. Then next one, we try to, option B has the possibility because the concentration of H3O plus is less than 2 exponent negative 3, show that they are ionized partially. But because in this question, Ka value is not given, so we cannot calculate the actual value. But then when we can check the option A. So when you check the option A, pH equal to negative log concentration H plus equal to negative log, the concentration H plus here is 2 exponent negative 3, so will equal to 2.7. So this value show that the acid is completely dissociated. So that's why option A also is not correct. So the correct answer will be option B. Question number 2. A saturated solution of lead-2 chloride means it's PbCl2 contain a concentration of A mole per decimeter cube. What is the solubility product? So solubility product refer to Ksp. So before we can calculate the Ksp value, we need to write the equation. Lead-2 chloride dissociate will produce Pb2 plus aqueous and also Cl negative aqueous, which will be in 2 mole to balance the equation. So initial change and equilibrium, we can directly go to equilibrium because initially there is no Pb2 plus and no Cl negative. So Pb2 plus will increase with A because the concentration given here is A, while for the Cl negative will be 2A. So when we write the Ksp expression, it is concentration Pb2 plus multiplied with concentration Cl negative raised to the power of 2. So substitute the value A 2A to the power of 2, so it will be equal to 4A cubed. So the answer is D. Let's proceed to question number 3. The pH of a solution consists of benzoic acid and sodium benzoate. So a solution with 2 substance and then 1 substance, for example, the benzoic acid is weak acid, while the sodium benzoate is the salt with conjugate base. So these two substances can form buffer solution. And since they are acidic buffer solution, so we can use the Henderson-Heisenberg formula. pH equal to pKa plus log concentration conjugate base over concentration weak acid. So negative log 6.5 exponent negative 5 plus log concentration conjugate base is 0.15 and weak acid is 0.25. Press the calculator, you will get the answer 3.97. Question 4. A solution is prepared by adding 50 ml of ethanoic acid into a 50 ml sodium ethanoate with the concentration 0.08 molar. Which of the following is true? So basically, as we know, the solution form is the buffer solution. So when you mix 2 substances with different concentration together, the concentration of CH3CO negative will be changed, and then the CH3COOH also will be changed. So both answers are wrong. Next, the pH of the solution form is the same as the pH of the original. So this is not correct. So the answer will be the donkey. Question number 5. What is meant by salt hydrolysis? As we know, salt hydrolysis equation help us to predict the pH of the salt. So before we can write the salt hydrolysis equation, we need to write the salt dissociation equation. Dissociation. So basically, for example, if we have NaCl, when we dissociate, it will have Na plus and Cl negative. So and then we will check whether Na plus can undergo hydrolysis or no. And then also Cl negative can undergo hydrolysis or no. So this equation generally is referred to salt hydrolysis. So if nothing happens, then the salt will be neutral. If one of them can have the reaction and then produce OH negative or negative ion, or H plus ion, then the salt will be either is basic or acidic. So option A, B, C, D is the most suitable because they mentioned salt hydrolysis occurs when there is a reaction between cation, anion, or both with the water. Okay. Question 6. 0.1 mole ethanol acid dissolved in water to form 500 ml solution. With this information, we are able to determine the concentration for the CH3COOH mole over volume, which will equal to 0.2 molar. Then we want to calculate the Ka value. So means that we need to write down the equation. CH3COOH dissociate in water, we're going to produce CH3COO minus and also H3O plus. So initial change equilibrium. Initially there is 0.2 molar aqueous CH3COOH, and then water we can ignore. There is no CH3CO negative and also H3O plus. Because of the reaction will move forward, which is minus 1.89 exponent negative 3, and then plus 1.89 exponent negative 3, plus 1.89 exponent negative 3. Why is 1.89 exponent negative 3 not x? Because in here the question already mentioned concentration of the hydronium ion is 1.89 exponent negative 3. So basically this is referred to x. So press the calculator. 0.2 minus 1.89 exponent negative 3, 1.89 exponent negative 3, and 1.89 exponent negative 3. After we have the ice table, then we will able to write the Ka expression, which is concentration CH3COO negative multiply with concentration H3O plus divide with the concentration of CH3COOH. So then now we can substitute the value in this column, or sorry, in this row, equilibrium row, into the Ka expression, and then you will get the answer 1.89 exponent negative 3 to the power of 2 divided by 0.2 minus 1.89 exponent negative 3. So the answer will 1.79 exponent negative 5. So this is the answer for question 6. Question 7. The following solutions are buffer except. So before we choose the answer, let's recall what are the buffer solution. Basically, buffer solution have to be consist of weak acid or weak base, and then it have to contain the salt with the conjugate base or acid. So when we check at here, all the both NH3 and the HC2H3O2 are the weak acid or weak base. So for the first part we already done. Then so the second part, we can notice that NH4 plus is the conjugate of NH3, and C2H3O2 also the conjugate, and this one NH4 plus again is the conjugate. Okay, how about the answer for this question will be C. Okay, because when I write this dissociation, NH4 C2H3O2, if this is the salt, when dissociate will produce NH4 plus C2H3O2 minus, at where we know that this NH4 plus is from weak base, and also these are from weak acid. When both are from weak acid and weak base, so they are not suitable be the salt. Let's continue to question number 8. Calculate the Ksp for the AgCl if the molar solubility in water is 1.3 exponent negative 5. So before we can write the Ksp expression, let's write the chemical equation. AgCl will produce Ag plus and also Cl negative. So based on here, the Ksp will equal to concentration Ag plus multiply with the concentration Cl negative. So which we say is XX. But in this question, they already give us the X value, which refer to 1.3 exponent negative 5. So we just substitute in 1.3 exponent negative 5 to the power of 2. So you press the calculator, you will get 1.69 exponent negative 10. So the answer for this question will be B. Last question for this video, question number 9. The Ksp value for magnesium fluoride is 6.9 exponent negative 9. What is the solubility in the NaF 0.1 molar? So when we compare these two, the F negative is the common ion. So we have again, we need to write the equation. Magnesium fluoride, solid, dissociate will produce Mg2 plus aqueous plus 2F negative aqueous. So initially there is no Mg2 plus from the MgF2, but there is 0.1 molar F negative, which is from the NaF. So 0. Magnesium fluoride is solid, we can ignore them. Mg2 plus X, and then this one will be plus 2X. So at equilibrium, we have X and 0.1 plus 2X. Because of the Ksp value is very small, exponent negative 9, very small, so that's why we can consider 0.1 plus 2X is also approximately equal to 0.1. Then we need to write out the Ksp expression, which is equal to Mg2 plus multiply with concentration F negative raised to the power of 2, at where we are given 6.9 exponent negative 9. Concentration Mg2 plus is X. Concentration F negative will be equal to 0.1 due to the Ksp value is very small. Okay, then when we substitute in the value, this one is, sorry, don't forget 0.1 raised to the power of 2. So X is equal to 6.9 exponent negative 9 over 0.1 raised to the power of 2. So the molar solubility will be donkey 6.9 exponent negative 7.